This is question 2. fxy xy equals to b. X squared plus y squared is smaller and equals to 1, 0 otherwise. For a, find b slightly above defined function is a valid joint PDF. So we can get integral of integral xy dx dy equals integral of b dx dy equals to b pi equals to 1. So we can get b equals to 1 over pi. For part b, find exy, eyx, and exy. Ex is equals to integral from negative infinite to infinite of integral from negative infinite to infinite fxy dx dy equals to 1 over pi times integral of from negative 1 to 1 x integral from negative square root of 1 minus x squared to square root 1 minus x squared 1 dy dx equals to 2 over pi times integral from negative 1 to 1 x square root of 1 minus x squared dx equals to 0. So we can get exy equals to 0, exy equals to 0, ey equals to 0, eyx equals to 0, eyx equals to 0, exy equals to 0. For part B, prove or disprove x and y are uncorrelated. When x is larger and equals to negative 1 and x is smaller than and equals to 1, fxx equals to integral from negative infinite to infinite fxy xy dy equals to integral from negative square root of 1 minus x squared to square root of 1 minus x squared 1 over pi dy equals to 2 over pi times square root of 1 minus x squared. When y is larger than and equals to negative 1 and y is smaller than and equals to 1, fyy equals to integral from negative infinite to infinite fxy xy dx equals to integral from negative square root of 1 minus y squared to square root of 1 minus y squared 1 over pi dx equals to 2 over pi times square root of 1 minus y squared. So fxx doesn't equals to fyy. Thus, we can get x and y are uncorrelated.